In this video, we're gonna study the 3 possible cases that may result when we do direct substitution. Of course, with more examples on direct substitution in limits. Let's start by defining 2 important quantities in limit. First, when we do direct substitution and we get 0 over 0, this is called an unspecified quantity. An unspecified quantity is undeterminate form, which doesn't give an exact answer. This means that 0 over 0 is for an existing number, but we cannot determine its value. So we need to use another way to find its value. Another definition, when we do direct substitution and we get a number, a real number other than 0 over 0, this is called an undefined quantity. Like when we get 3 over 0, 5 over 0, or say 9 over 0, or whatever, any real number over 0, this is called an undefined quantity. In math, an undefined quantity is meaningless form, and this number doesn't exist. And in this case, we can say that the limit doesn't exist at this point, or we can say that there is no limit at this point. Now, let's start by taking some examples on direct substitution. Number 1, find the limit of x squared plus 3x plus 5 as x tends to negative 1. So we need to evaluate this limit or this function when x tends to negative 1. By direct substitution, we can just find f of negative 1. So let's do direct substitution. So f of x is equal to x squared plus 3x plus 5. And we need to evaluate it as x tends to negative 1, so we need to find f of negative 1. This is called direct substitution. So let's substitute each x by negative 1. So negative 1 squared plus 3 times negative 1 plus 5. This is equal to negative 1 squared, the negative sign is cancelled because of the even power, so 1. 3 times negative 1 to be negative 3 plus 5 to be 5 and 1 to be 6 minus 3 to be 3. So f of negative 1 is equal to 3. This means that the limit of fx as x tends to negative 1 is equal to 3. This is called direct substitution. Another example, we need to find limit of 3x minus 4 over x squared minus 4 as x tends to 2. So, fx is equal to 3x minus 4 over x squared minus 4 as x tends to 2. So, by direct substitution, let's find f of 2. This is equal to 3 times 2, 3x means 3 times 2 minus 4 over x is 2, so 2 squared minus 4. This is equal to 6 minus 4 over 4 minus 4 to be 2 over 0. 2 over 0, this is an undefined quantity. So, if we get an undefined quantity, so we say simply that there is no limit at x equal 2 or the limit doesn't exist at x equal 2. The limit of x squared minus 4 is over 3x squared plus 11x plus 10 as x tends to negative 2. So fx is equal to x squared minus 4 over 3x squared plus 11x plus 10 as x tends to negative 2. So find f of negative 2. This is equal to x squared means negative 2 squared minus 4 over 3 times negative 2 squared plus 11 times negative 2 plus 10. This is called direct substitution. This is equal to negative 2 squared means 4. The negative sign is cancelled because of the even power, minus 4 over 3 times negative 2 squared to be 4 times 3 to be 12, and 11 times negative 2 to be negative 22 plus 10. Up we have 4 minus 4 to be 0, and down we have 12 and 10 to be 22 minus 22 to be 0, so 0 over 0. 0 over 0 is a specified quantity. So we have to do another way to get the value of the function as x tends to negative 2. So let's use the previous definition. So as x tends to a, x is equal to a plus h, and when x tends to a, h tends to 0, and the limit of fx as x tends to a is equal to the limit of f of a plus h as h tends to 0. So as x tends to negative 2, h tends to 0, and we have as x tends to a, x is equal to a plus h. So find f of a plus h. So f of negative 2 plus h is equal to x squared, so negative 2 plus h squared minus 4 over 3 times x squared to be negative 2 plus h all squared plus 11 times negative 2 plus h, and finally plus 10. We need to expand many perfect squares. This is equal up and down. So this is equal to negative 2 squared to be 4 plus square of the first plus, should be plus square of the second, so plus h squared. Take the first times the second times 2, so negative 2 times h to be negative 2h times 2 to be negative 4h minus 4. We can safely remove the bracket. Now this is the same as this, so we don't need to repeat it. So 3 times the same quantity, so 3 times 4 minus 4h plus h squared, so minus negative 2 times 11 to be negative 22, and 11 times h to be plus 11h and plus 10. Now simplify by distribution. This is equal to up 4 minus 4, we can safely remove the brackets as we don't have a negative sign outside or a number. 4 minus 4 to be 0, and start by the higher power of h, so h squared minus 4h. Down we can distribute 3 times 4 to be 12 minus 3 times 4 to be 12h and plus 3h squared minus 22 plus 11h plus 10. Now simplify. 10 and 12 to be 22 minus 22 to be 0. And term is cancelled. Now start by the higher power of h. This is equal to h squared minus 4h, and down start by h squared. So 3h squared in minus 12h plus 11h to be negative h. To simplify, up and down we can take out a common factor, least power of h as a common factor. So up we have h as a common factor. Divide each term by h, so h squared divided by h to be h. You subtract 1 from the power, and minus 4 h divided by h to be 4, minus 4, and down. So take out h as a common factor and divide each term by h. 3h squared divided by h to be 3h, and minus h divided by h to be 1. Now cancel the h up and down. Finally, this is equal to f of negative 2 plus h. So f of negative 2 plus h is equal to h minus 4 over 3h minus 1. And as x tends to negative 2 by the definition, h will tend to 0. So substitute 0 for h in the previous value. So f of negative 2 plus h is equal to 0 minus 4 to be negative 4 over 3h, or 3 times 0 to be 0, minus 1 to be negative 1, negative 4 over negative 1 to be 4. So by definition, the limit of fx as x tends to negative 2 is equal to 4.